All right, so lesson number 12, we're going to be talking about arithmetic with complex numbers. Now remember, a complex number has a real part and an imaginary part, and sometimes you see it written as A plus BI. Okay, so we have the real part and then the imaginary part. And we can draw those on the imaginary plane or the imaginary coordinate system, where the horizontal axis is your real axis and your imaginary axis or imaginary number line is vertical, kind of like the y-axis. So if we look at this one, it says, what does this path mean? So if we look at this path, we're starting at 0, then we are going 2 units in the right direct to the right, or a real direction. Whoops. 2 units to the right. Then from there we're going 3 units up on the imaginary axis, and then we're going 1, 2, 3, 4, 5, 6, 7, 8 units. 8 units to the left, and then down 1, 2, 3, 4, 5, 6, 7, 8. Then down 8 units. Now, where did we end up? What is this complex number? So it's negative 1, 2, 3, 4, 5, 6. So A is negative 6, then 1, 2, 3, 4, 5 down, minus 5i. Again, it's not an xy coordinate pair. It is the complex number negative 6, negative 6 minus 5i. So if we look at the next page, it says this diagram represents 2 plus 3i plus negative 8 minus 8i. So part A says, how do you see 2 plus 3i represented? So if we start from 0, we went right 2 and up 3. Move right 2, then up 3. Because 2 is in the real number, and 3i is our imaginary number. So we ended right there. And then how do we see negative 8 minus 8i represented? Well, we go from here, and I'm going to write, we added 2 and then 3i. From here, we go backwards or to the left. 1, 2, 3, 4, 5, 6, 7, 8. We went minus 8 on the real number line, and then down 1, 2, 3, 4, 5, 6, 7, 8. We went negative 8i on the imaginary number line. So how do we see that represented? Is from the previous step, in the previous question, move left 8 and down 8. What complex number does A represent? We wrote that on the previous page. That was negative 6 minus 5i. Okay. And letter D, add like terms in the expression 2 plus 3i plus negative 8 minus 8i. So like terms, we're going to add our real parts together and add your imaginary parts together. So 2 plus negative 8 is negative 6. and positive 3i plus negative 8i, that is negative 5i. And you may notice that it's the exact same values that we got when we drew it out and counted that way. So for adding complex numbers, we're going to add the real parts together and then add the imaginary parts together. We can't, cross-contaminate our real and imaginary parts. So on the next page, write the sum and difference in the form a plus bi, where a and b are real numbers. So it says check your work by using a diagram, but we don't necessarily need to. So for letter A, we're going to add negative 3 plus 4, which is 1. And then positive 2i plus negative 5i, which is negative 3i. So this complex number is 1 minus 3i. All right, letter B, again, adding the real parts together, negative 37 plus 11, that is negative 26. And then negative 45i plus 81i, that is 36i. So this complex number is going to be negative 26 plus 36i. Now, when you are subtracting, you need to be careful because this subtraction gets distributed to both things. So you can think of this as negative 3 plus 2i minus 4 plus 5i. And then combine your like terms. Negative 3 plus negative 4 equals negative 7. And then 2i plus 5i is 7i. So negative 7 plus 7i is our complex number. All right, then the last one, again, if we need to make sure we distribute that negative. And then add up our real parts. Negative 37 plus negative 11, that's negative 48. And then negative 45i minus 81i is negative 126i. So again, this complex number is going to be negative 48 minus 126i. So adding them is really easy. You're essentially combining like terms. You add your real parts and your imaginary parts together. On the next page, we're going to talk about multiplying in the complex plane. So when we're multiplying, some of the rules here are a little bit different. So let's draw this on our number line. We have 2. 2 to the second power, which is 4. 2 to the third power is 8. And 2 to the fourth power is 16. So what do you know about the arrangements of these points? Like the space between them is doubling each time. So there's 2 numbers between 2 and 4. There's 4 numbers between 4 and 8. There's 8 numbers between 8 and 16, so that the distance between the 2 points is doubling. So the distance between points is doubling. Now let's look at, instead of 2, 2i. So we have 2i, 2i to the second power, 2i to the third power, 2i to the fourth power. So we're going to write it in the form a plus bi. So if we have 2 to the I, 2 times I, that's just 2i. Now 2i squared, well, I squared is negative 1. So I'm going to write it down here where we have 2 times negative 1. Oops. So I'm going to write it down here. We have 2 squared, which is 4. So 2i squared is 4i squared. 4 times negative 1 is negative 4. So our next value is negative 4. Now 2i to the third, 2i to the third, well, 2 to the third is 8, so we have 8i to the third. Well, I to the third is really I squared times I. And we know I squared is negative 1, so this is going to be negative 8 times I. Now 2i to the fourth, 2i to the fourth, that's 2 to the fourth times I to the fourth. 2 to the fourth is 16. And then I to the fourth, you can write as I squared times I squared, because when we multiply, we can add the exponents. So I'm going backwards. If I had I to the fourth, I can rewrite it as I squared times I squared, because if you add those exponents, you get I to the fourth. Well, I squared is negative 1. 16 times negative 1 times negative 1 is positive 16. So you see, when we're taking 2i and raising it to different powers, sometimes we get an imaginary number, sometimes we get a real number. So if we plot those, plot those on these number lines, 2i is right here. Then we have negative 4. Then we have negative 8i. Then we have positive 16. Oops. Positive 16. So what do you notice about the arrangements of these points? You know, that they're changing what number line we're on. Sometimes we're on the imaginary number line, up and down. Sometimes we're on the real number line, going left and right. The points alternate between the imaginary and real number lines. So what that means is that when we multiply complex numbers, we might get a real answer. Because 2i squared is really 2i times 2i. Two imaginary numbers being multiplied together, and we get a real answer. Whereas when we were adding complex numbers, we always got a complex answer. We always got I in our answer. When we're multiplying, that may not be the case. You know, and we'll explore more of that in the next few lessons. So we're not going to do the Are You Ready for More? I want to go to the summary. So again, when we add a real number with an imaginary number, we get that complex number, and it's in the form a plus bi, with the real part is a, and the imaginary part is b. When we add or subtract complex numbers, we add or subtract the real parts together, and then add or subtract the imaginary parts together. And you can see in this example, we added 2 and 4, and we added 3i, we added 3i and 5i. And when you subtract, you got to remember to change it to adding the opposite, or distributing the negative sign. Now, when we raise an imaginary number to a power, we are going to alternate or cut. Now, when we have an imaginary number raised to a power, we're going to utilize that I squared is equal to negative 1 to simplify things. So, for example, 4i to the third power, okay, we have 4 to the third power, so 4 times 4 times 4 is 64. And then I to the third power, we can rewrite as I squared times I, and changing I squared to negative 1 will now allow us to multiply 64 and negative 1, and that will leave us with negative 64i. So we can multiply real and imaginary parts together, but we can't add real and imaginary parts together. Okay? So, like I said, tomorrow we're going to explore more about multiplying complex numbers because those are a little bit tricky, but adding them is real simple. Just keep the real parts together and keep the imaginary parts together. So that's it for the video. Thanks for watching. Make sure to like it and subscribe.